address of the next instruction that you want to execute. Means whenever we are performing number of instructions, when one instruction has been moved to the processor and it has start executing, then program counter holds the next instruction. Means whenever like basically our execution starts from the program counter only, because it gives the address, then further instruction can be executed. So you must understood what is program counter. Now next special purpose register is stack pointer. Now stack pointer, as its name is clearing, it is one of the pointer. It is pointing towards the stack. Now what is a stack? Now stack was the one what is a stack? It is an array. Now stack is an array that works on LIFO, means it is also for storing data only. Now stack pointer is of 16-bit that hold the memory location. What is the memory address of the top of the stack? That value is contained in the stack pointer. Whenever we are incrementing anything, stack pointer gets, when we are inserting anything, then stack pointer increments. When we are deleting anything, when we are doing pop operation, we were having basically two operations, push operation and pop operation. When we are performing push operation, then stack pointer gets incremented. When we are performing pop operation, then stack pointer gets decremented. So this was, now we have discussed basically three special purpose. Accumulator, it is of 8 bits. Program counter holding the memory address of the next instruction, 16 bits. Stack pointer holding the memory address of the top of the stack, that is also of 16 bit. Now we move on to another special purpose register, that is instruction register. Now instruction register is of 8 bit and it is also known as IR. Now what it holds is that it holds the opcode of the instruction. Whatever instruction is need to be executed, it is holding the opcode of the instruction, which will be further decoded and executed. Means this register will be giving the opcode and that will be further decoded and executed. Now whenever any instruction is fetched from the memory, it is loaded. Whenever we are when we are loading any instruction, it is fetched in this instruction register. Now further it will be decoded and executed. Okay, so you must have hold. Now program counter was holding the address, stack pointer was holding the top of the address of the top of the stack, instruction register holding the opcode of the instruction which needs to be further decoded and executed. Now next we move on to these temporary registers. These are of also 8 bit. Now these are holding the data. During whenever we are performing any arithmetic and logic operation, the intermediate data is held by the temporary registers. Means second value is also taken from the temporary register and when intermediate value is also stored. Now user will be giving the value to register B, C, D. Now that value further will be gone to temporary register, that will be given to ALU. It is not accessible by the programmer or the user. It is not accessible. It is only accessible by the processor. So second value will be given to any of these registers. These will be transferred to temporary register, that will be further transferred to ALU. Now we move on to our next one, flag flip-flop. These are also known as flag registers. These are also of 8 bit, but only 5 bits have been known and the remaining 3 have not been known. Now in this part, actually flag register is also one of the question for 5 marks or 10 marks, but when we are discussing the architecture, then we will not be going very deep because we need to discuss all the units, but I will give you the overview of this flag registers. Now what is flag register is? It is containing 5 types of flags. First one is the carry flag. Now carry flag will be set, means the value of carry flag will be 1 when carry is generated after performing arithmetic logic operation. Second flag is 0 flag. Now 0 flag will be 0 when our result of the arithmetic logic operation will be 0. Third one is the parity flag. Now parity flag will be 1 when our result contains even number of ones. Okay, now auxiliary carry flag is 1 when any carry has been transferred from bit D3 to D4, means when carry is transferred from one nibble to another, then that is known as, auxiliary carry flag will be set to 1. Now sign flag. Now sign flag is set 1 if after performing the arithmetic and logic operation, whenever our result is negative or positive. If our result is negative, then sign flag will be 1. If our result is positive, then sign flag will be 0. Okay, So these were the basically special purpose registers: accumulator, temporary register, flag flip-flops or flag register, instruction register, stack pointer, program counter. So basically maximum part we have discussed. Now the remaining ones, we will be going one by one to the remaining ones. Now remaining ones are the increment or decrement address latch. Now but it is also of 16-bit. Whenever now in the previous we have studied that whenever we are inserting any value, then program counter then the value of stack pointer will be incremented. When we are popping any value, when we are deleting any value, stack pointer value will be gets decrement. So value gets increment or decrement using this increment or decrement address latch only. Okay, now it is the 16-bit special purpose register that will be incrementing the content of stack pointer or program counter. Okay, now stack pointer value will be increment also and decrement also, but program counter value will always be increment. Now next we move on to address buffer. Now what is address buffer? It is a 8-bit unidirectional address bus. Means it is holding the higher order address bus. Means A8 to A15 address are held by address bus. Next one is the address or data buffer. Now it is also of 8-bit. It is holding the lower order addresses or the higher order lower order addresses or data D0 to D7. So means it is doing two operations. It can hold the address also and it can hold the data also. Now next we move on to this interrupt control. This is also one of the question only, like you can get 5 marks question that what are the interrupts, but in this part we'll basically discuss only what is interrupt control. It is containing 5 interrupt input signals. Those are trap, RST 7.5, 6.5, 5.5, INTA, INTR. So if you want, you can discuss one by one, like you can just write one line, like suppose INTR is the interrupt request. That is it is a request received by the microprocessor. Whenever it accepts the request, it gives the acknowledgement, and the remaining one are the, you can like whether these are vectored or non-vectored, whether they are maskable or non-maskable. If you want, you can write. Means it depends upon the time. Okay, that if you are having time, you can discuss this one also. So this is basically the interrupt control. Basically you can write it with interrupt control is that all the interrupts that are received by the processor are using interrupt control. For receiving the interrupt, we are having interrupt request, and for acknowledging we are having INT. The remaining are the interrupts. Okay, now last one we move on. Now if you can see, we have discussed each unit, only we left with the serial input output control. Now this block controls the serial data transmission. Now in this, the data bits are sent over a single line. Means then we will be getting the input 1 bit at a time, and we will be sending the output also at a 1 bit at a time. So basically it is for the data transmission. Serial input output control is of data transmission. So this was all about 8085 block diagram. In the class we have also discussed this question also, as it was important. So again I have discussed in this, and remember not to leave this question at all. Thank you.